Now let's see what a hyperbola is. Okay, this is what a hyperbola looks like, right? And you can see that it's similar to an ellipse. It's basically an inverted ellipse, right? It's similar to an ellipse. It's comprised of two parabolas. One is this one, and the other is this one, right? The only difference is that both of these parabolas are inverted, right? So hence I give it the name an inverted ellipse. It's similar to an ellipse also because it has two foci, right? And it has this equation that holds true for all hyperbolas. Now, in case of an ellipse, this equation was f1p plus f2p is equal to some constant. The only difference between both of these equations is this sign, and it exists because of the inversion of the parabolas. Now, again, this equation, what does it mean? Well, if you subtract this distance from this distance, it will always be a constant in case of a hyperbola, right? So if you take any point on this hyperbola, this equation will hold true. Now let's dive deeper into the equation of a hyperbola. Now these are two possible cases. Similar to an ellipse, which also had two possible cases, this has two possible cases as well, right? Now let's take the first one as an example, and all of the rules over here will apply to the second one as well. Now, you see this equation? Well, here's the thing. You can see that this A over here, that's just the distance from the center to the vertex, right? And by the way, both the distances are the same, right? Because hyperbolas are symmetrical, as in the case of an ellipse. So we'll just take this parabola as an example here first. Now, this A is the distance from the center to the vertex, okay? Now, this C over here, right? That's basically just the distance from the center to the foci. The focus. Foci is plural. The focus, any one of these focus, okay? And basically, A, again, the distance from the center to the vertex. C is the distance from the center to the focus. What is B? Well, here's the thing. B will lie on in this axis, right? And this is B. Basically, you have a formula. C squared is equal to A squared plus B squared. So C is equal to under root A squared plus B squared. So what that means is that, let me just clear this up. It means that this is the distance B, right? This is the distance A, right? And this is the distance C, okay? And basically, B would be, well, B is equal to C square minus A square whole under root. And you can calculate this distance now. And since once you have this distance, you can just simply apply this formula in case of this type of ellipse. If the axis of symmetry, in this case, is the y-axis, if the axis of symmetry of the hyperbola is the x-axis, which is in this case, you'll have this equation, right? And yeah, that's really about it for a hyperbola, and I hope this is understandable to you. Just remember this equation, right? C is the distance from the center to the focus. A is the distance from the center to the vertex. And once you have those, you can calculate what B is. Okay? And once you have B, you can apply this formula, or in this case, this formula. And yeah, that's about it.